In this illustration, we intend to simulate seismic behavior of obliquely stiffened steel plate shear wall with openings in the Abacus software. As you observe in the picture, the model includes top beam, middle beam, column plate, channel stiffener, and square tube. In this picture, you can observe the steel plate shear wall having been made inside the laboratory. And in this picture, the steel plate shear wall having been simulated in the Abacus software can be observed. In this problem, a cyclic loading is applied to the steel shear wall, and then the hysteresis diagram of the model will be drawn. In this picture, the hysteresis diagram obtained from the Abacus software has been compared with the laboratory results. As you observe, there is a good conformity between the results obtained from the Abacus software with the laboratory results. In these pictures, the final deformation of the steel shear wall can be observed. In this picture, the formation of the middle beam in the Abacus software and in the laboratory model have been compared together. Here you can observe the buckling occurred both in the Abacus software and in the laboratory sample, and it has actually occurred in the top beam. Actually, we intend to simulate this article in the Abacus software. The article is entitled Experimental and Numerical Study on Seismic Behavior of Obliquely Stiffened Steel Plate Shear Walls with Openings. Here, we intend to draw the geometric shape of top beam. As you observe, the length of the web is 350 millimeters and the length of the flange is equal to 175 millimeters. As it can be observed in the picture, the length of the beam is the sum of 300 plus 1400 plus 300 that come to 2000 millimeters. So here I will enter the length of the beam equal to 2000 millimeters. Here I will enter geometric shape of square tube. Into the assembly module, first rotate that 90 degrees about x-axis. I will click on Translate Instance, select Square Tube, done. First, I will select this point, then this point, and OK. Here I will select Plate, Channel Stiffeners, and Square Tube, done. In this table, you can observe the properties of different parts. First, I intend to define the properties of plate. I will click on Mechanical menu, select Elasticity and Elastic. In this problem, Young modulus is equal to 206,000 megapascal. The Poisson ratio is equal to 0.3. I will click on Mechanical menu, select Plasticity and Plastic. Yield stress is equal to 315.74 megapascal. I will click on Create Section. The plate is 3 millimeters thick. I will click on Create Load, select Axial Pressure Step. Here I will select Concentrated Force and Continue. I will select these two reference points. Done. As you observe here, 260 kilonewton force is applied to each one of the columns. In the next step, we intend to draw the hysteresis diagram of the model. Actually, we intend to draw this diagram in the Abacus software. In this diagram, the horizontal axis is displacement and the vertical axis is force. I will click on Create XY Data, select ODB Field Output and continue. Here I will select Unique Nodal, then Reaction Force in Z direction. In the next step, I will select Displacement in Z direction. Here I will select Set 6, that is related to cyclic loading. I will click on Create XY Data, select Operate on XY Data and continue. Here I will select all reaction forces. Here I will select Sum option, then click on Add to Expression, then on Save As. In the next step, I will click on Combine. First, I will select U3, then Total Force, and click on Save As. Here you observe the hysteresis diagram of the model. I will transfer this diagram to the Excel software. The first column is displacement, the unit of which is millimeter. The second column is force, the unit of which is Newton. Here the diagram marked out with green color is the one obtained from the Abacus software. As you observe, the results obtained from the Abacus software are so close to the laboratory results, indicating that this problem has been simulated correctly in the Abacus software. In fact, the results obtained from the Abacus software have a good conformity to those mentioned in the article. Here we intend to compare the deformations obtained from the Abacus software with those gained from laboratory results. As you observe in this picture, this area has been damaged and a buckling has occurred, and this deformation can be observed here. Here you can observe the deformation having occurred to the top beam. This deformation can be also observed evidently in the Abacus software, and we can see that this area has undergone a deformation. Actually, the deformations obtained from the Abacus software are quite concordant with those occurred in the laboratory results.